Hello there. Welcome back to another video where I have some free time to code. And in this video, we will be doing the implementations for nobita.h, at least to try and make an executable at least, a separate executable from the build file. Since last time, we defined the APIs to define the executables that needed to be built with the sources. So let us get into trying making the implementation. Though, let's see. I need the LSP, so we need to redefine this back. And it seems like the Clang daemon is treating this as a C++ header. So let us change that with compile flags and set the standard into C99 at least. Let's see. How do I do this again? LSP restart. And then we should try to create the implementation of these tracks. Nobita build and target. The dogs are howling outside, but I hope it cannot be heard here. Struct Nobita target. But we'll save that for later. First, we need the build X variable that would be needed for every other function here. Oops, not target, build. So in this build file, the main build tree would have to depend on other executables and libraries to be built. So it would need the Nobita targets and should call it, I guess, dep exes and dep libraries. Oops. And then with how the dynamic array macros work, we need some backup variables to tell how much is used and the current capacity, which I call size. And same for the exe. Just replace lib with the exe. And the target itself would take a name and then a boolean if it's already built. So that if an executable depends on a library, well, the library would be built first. Though in here, I want to automatically build the library first, then the executable. So when the executable gets built, it would try to build the dependencies first, and with this flag, it can skip the library that has already been built. And then we need the compiler, the archiver, the option for the compiler to output an object file, and the option to change the name of the output file. For the archiver, we need its creation options. And what else? The compile flags. This needs to be a double pointer since it's an array of characters, array of strings. Sorry. And then this should be a dynamic array So it needs the backup side, the backup variables. No, why am I calling it backup variables? Sidekick variables. Compile flags, the source files relative to the final build executable. So, and then the link flags. So that's that. And then let's try to implement creating an executable dependency and these other things. So first, since these three return the same thing, but just changes the target type, which I forgot to add here. So let's just create an enum of the target type. What should we call this? Oh, so let's say an executable, and then a shared library, and then a static library. And we can just set the type here, call it target type. And since targets can depend on other targets, so we should add that. So sadly, it's another uh, dynamic array, so there would be a lot of allocations. Should be the same .exes. You know what? Let's just copy and paste it from here. There you go. And then what else? That should be it for now, as we're only trying to build an executable. So again, these three output the same thing. So let's try to output a central one. Nobita target pointer, build, add, target. We'll take the build variable and a name. And since this should not be available to the user, let's just make this a static function. And then we can allocate the target with malloc size of t and return this. Though, if I am to save code lines, so I don't need to set build to false and the other variables to 0 or null, I can just call calloc, but I will set it to null myself. The archiver, compiler, and then the options. Where is it? Here. And then where's the other one? Here. Then the archiver option. After these, we have to call the vector init function on t to initialize C flags, the sources, and then the link flags, and return it here. Next would be to take the output of this add target, where is it? Here. And give it the same arguments, but set, hold on, oops, I misspelled it. Let's give it the executable type. And then you can return this pointer after appending it as a dependency of the main build variable. Exes, and then this E. But the Clang daemon is complaining about the suspicious usage of size of the reference. But don't worry, we know what we're doing for now. You can just copy and paste this and call it a shared library. Maybe it's better if I set this as L and change this to shared. Ah, another one would be change this to the library dependency. And that's it. Same thing for the static library, but just change this to static. What else? Ah, yes, the name, and if it's already built, the build should be false, and the name variable should be malloc site, and take the length of the name string plus 1, and sometimes you don't need size of char since in the standard it's 1, but who knows on what system this will actually be run, but I'm not too worried about that. Next, just assert that this is not null, and if it is, give them the sad reality of them needing to buy more RAM. Bye. And then we can copy the name to here. Does this return something though? It does. Well, we're not actually gonna do anything with the return of this return value. So there you go. This is gonna be a pain to free later, but we can. So let's add that here and actually create the build variable. Nobita build B, and in it the dependency arrays. Actually, last thing, you have to free it. Though before removing those vectors, you have to free something else. And, well, it's less than the amount of libraries. We have to free. No, let's set it to target. Just call it T B that depth and libraries. I. Now we can free the compiler. Oops, the archiver and the options. Next up would be the archiver. What else is in this thing? I guess freeing the flags one by one. So let us try to free that. Wait a minute. I should check on here. C flags used II plus plus. Then we can free these C flags. Just call II. And then C flags would change into, let's change it to the link flag first. And then into sources. That's about it. Now it's complaining it's not assignable since this is not a pointer. Though we can set this into just one for loop by just saying, by adding the amount of exes here, and t shall be initialized with a condition, while I is less than dependencies of libraries. Well, set t into the indexing library, but if it's greater, then why is it adding this thing? You set it to the index, but you subtract the amount of libraries first. So that can happen. So just one for loop. And we can add these here too as well to reduce the amount of for loops. Though I don't want to do that now, since it's more readable that way. Then let's try to actually build something, I guess. Though I need to create the implementations for these first. Oops. Well then, if no, the compiler is absolutely necessary. So that's now. Then we return or we panic. But where can I add a flag for this thing? Can I add something like non-nullable here? No. Restrict was a keyword, but where's non-nullable? It's not here. Hmm, where did I see that? I don't remember. Oops. Capital M. Nope, it's restrict here. Where did I see that again? Sit in exec VP. Surprisingly not. Anyways, we'll deal with the edge cases later if this applied argument is null. First, we add the compiler by allocating enough memory for it. So get the length of the compiler name plus 1 and multiply by the size of characters. Check if it's null, wrong spelling. Then we can copy that. Though, let's just get straight into panicking. If the compiler is set to null, then you're already doing something wrong. To null. Though, can I do this as a static assert? No. I wonder if it's in here. It is. Huh. It changed in C23? Okay. So we can just do a static assert here. What is wrong? Wait, when is this added? Let's try C11. It's not an integral constant expression. Well, that's understandable. So we'll just deal with normal assert for now. Though I wonder if there's a way to do it. Next is If you are a library, and the type, or is it the target type, is equal to a shared library or a static library, then you messed up. So just say false and give some complaint. Please do not set the archiver to null if you're building a static, no, not just static, any library. There you go. And then you can do an else on this. No, 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 no. I should have separated this to another if statement and set it as a black if statement, a block statement, and with the else function, we do the same thing here, but we'll be replacing CC with AR. Now it might be better if I made this a block statement too. There you go. And then the build tool options would be largely the same here. So should assert it. CC to object or out file. And we give them a message, not set any of the compiler options to null. And we just do the same thing. We allocate enough memory for it. Starlen, CC, add 1, multiply by the size of character. Oops, I've done that wrong. Nope, I actually done it correctly. And then my output should be, nope. Why is it not showing up though? Oh well. I messed it up. There you go. Then we can do an assert first. Say this is not null. And just say buy more RAM. It's getting repetitive, but it's a bit needed. and just copy it now. Oops. Wait a second. There. That is done. Then we can check the target type and do this for adding the options. We can replace AR with create options. Though this is wrong. Wait, wait a minute. We can do that. Next up, the assert false and the warning message. AR create to null if you're building a library. That's the tool options done. Hold on. I screwed that one up. Next up, the prefix value. Now we have to check if this is an absolute path. First, we say that prefix should not be null. Prefix to null. And then, what else? Assert that the first prefix should be a slash character. Say that prefix path should be an absolute path. Oops. And then we can do the malloc assert and stir copy once more. Wait, I did not add it, huh? Okay. Well, we can add that here now. Prefix. And we can go to set prefix once again. So allocate enough for prefix and its null character. And assert. We might be going overtime here, eh? Oops. Then copy it to prefix from prefix. Now adding the C flags. So now, finally, something we can copy and paste. First, we need standard arg, which we don't have yet. So we can deal with periodic functions. So we can create this VA list and initialize it from the last function argument before the ellipsis, then end it they initialize it. After that, you can check the arg that we have gotten if it's not equal to null. But first, we have to create arg from va_arg with va as the argument and the type. We do it once again here at the bottom to actually cycle through it. Then create another character pointer that we allocate ourselves from the length of the argument plus 1 times size of car, a vehicle, a char. Assert once more. This is gonna be a pain to replace if it becomes a production something, production code. But maybe it will not. Maybe it will. Who knows? Then we can copy the arg into here and actually append it to the target C flags. Now, I wonder why it's not complaining when I dereference a double character pointer with this macro. But it complains if I use another, if I use a struct. Now that's just weird. I wonder if there is a rule for that. We can just replace C flags here with sources though. And then the link flags. There you go. We're done with the implementation of the APIs. Now the build step should try to create a executable. So it will take an exe pointer, and we should know how to execute commands here. In Linux, if I'm correct, we have to use fork and execvp so we can separate the process from here, from the build executable. Since execvp replaces the current process with the new one that just executed. So let's try to create something like that. Combine it, fork exec. And what kind of arguments does this take? Nothing. And it returns a process ID. And I need the Unix standard library. Add that here. And then where's fork exec? So we get a process ID from fork. But where does this come from? Come from sys types. Though I wonder if that's still a part of the standard library. The cross-platform standard library, not the implementation specific one. So let's put it in the middle here. And then where is it? Now it doesn't have any complaints. Now if, wait, how does this work again? And to work. So it returns a process ID and then what? It has the same memory layout, but changes in the child's memory layout doesn't affect the parent or vice versa. But how? Wait a minute. Am I missing something? How does the program know if it's the child process or the parent process? The child has his own unique process ID. No? Okay. On success, the process ID of the child is returned in the parent and 0 is returned in the child. So if it's 0, then it's the child process. And we can use exec or something to do it, to execute the compile commands. So man to exec VP, I guess. Oh, there are multiple of these. I want the one that takes a double pointer, a pointer to a car array. So exec VP should be good since I'm not going to use the environment variables. So exec VP and then what else? Is there any condition for the character array? How does it know when does the array end? So it's an array to null terminated strings, and then the array pointers must be terminated by a null pointer. So null should be last. So we can just take a command pointer, and that should be it. Though, I can just add to the definition of the target another vector that we can use for this. So instead of LD flags, let's call it full CMD. And with this command that will be passed here to fork exec, it will do exec VP. Wait a minute. There, it's a double pointer. So it can take CMD, and its first argument wants it to be the file, which already is the first index in the CMD array. Now, exec VP or will not return if it's successful, but if it does, well, it will just exit unsuccessfully anyway. So exit failure. Wait, what does that complex.h? It's in standard library though here. I wonder what that is. I'll search that for later. But for now, does do we need to wait for this process to finish explicitly or does it not? Is there something like await PID? There is. So this wait PID takes a process ID, and an integer pointer for it to put the status into. Here's what I was looking for earlier, the flag for if it's nullable or not. But this thing seems like it is. And what about the options? See below. Wait a minute, where is it? Hmm, it's did I miss it? Since when? By default, wait the ID waits only for determinate children, but this behavior is modifiable via the options argument as described below. The value of the process ID can be this is an OR of 0 or more following constants. Hmm. Well, screw that. You just set it to 0 and hope for the best. The status variable can be null, set that to 0. So, where did this come from? Sys wait. So we can execute that. And then here in the build executable, we can just append the arguments to the full command. Though I'm pretty sure I have not initialized the full command yet. And yes, I was correct. Oops. There you go. And finally, actually try to build something. We're already over scheduled here. Set that to static as that will not be used by the user of this library. So first, we can append the compiler to the full CMD. Oops. Though the next one, the C flags is also a vector. So I wonder, no, I should just create a macro to append a vector to another vector. So we can do vector append vector. So we should change up the names a bit. Destination, test name, and the source pointer, source track, and what is the name of the source. And then another do while loop. And since we're already using standard boolean, just set it to false. Oops. This as well. Now we can append it. So how do we want to append this? We can do a straight mem copy, but that would be bad since it did not go through the right procedures of appending the vector here, since it has to resize it, we can just add the logic here or just add the for loop that would take every source and put it in the destination via the vector append macro. And that's the route I want to take. First, I have to think of the name though. The iterator name, since it might collide with other for loops, just in case. So, can just name it something like that and append the source name as well, just in case. Now, it should not collide with the name of other iterators, though the name gets a bit long and a pain to type. So we'll just go through standard procedures here and set and check if it's over the size, no, used, and increment it by 1. Man, this is already chaotic. Plus plus. Now then, we can append it, vector append the to the destination from the source via this iterator. Oh my, that's a pain. There you go. We are done. But I'm gonna pause here for a second. I need to eat. You know what? No, let's get to finishing this thing. At least try to create an executable, at least. So let's get back to the build.exe. And instead of just appending the compiler, we can append the vector to the command from itself and the C flags. Then it can append the output option nope, not to object, but to output. Hold on. File output option. I want to append its name. So the executable would be based on the name. E equals cmd e dot name. Next would be the link flags, but I'm forgetting something else. Let's write the sources. Now the link flags. Oops. Full command, then link flags. Lastly, it wants null. So we'll give it null. And now we can call fork exec with e full command. What do you mean undeclared identifier? Wait, did I forget to set its type? I don't think so. Oops. No, I don't think I did. So what is the problem? Let's see. Hmm. Oh, I screwed up with this one little underscore. Wait a minute. Should be something like this. There. What else? What else? Hmm. Oh, there. Here as well. There you go. Now that is fixed. And let's try to build an executable. Though we need to call the build first. We can use the same thing here. So build exe. There you go. But you don't really need this and this. I'm gonna pause now for a second. Well, after this pause, after the pause, I have checked the code and it seemed fine. And I've already eaten, except for this one though. Except for this part of the code, that is not fine. So we can set build to get that. And then here though, I want it to print the command. So we will loop the commands here. What can I do here? I can get a copy of command pointer. And then while that is not null, then we can know how much space we need to allocate for this full command string. So we can add the length of cmd2 plus 1 since we'll be appending spaces to it. And while that's the case, we would also need to append the null character. So that is that. and we add 1 to CMD2. Next step would be actually appending the commands to the full command string after allocating the full command length there. Malloc. No, let's just call it calloc so it's initialized to 0. Calloc full command length times size of car. There you go. No, we can just separate it like that. And then, well, command, you increment command, and you concatenate it to full CMD, the command, and the space. Now, we can print the full command, say, S, and new line, full command, then free it. Well, not print, it's printf after calling standard IO. I guess that is that for now. Now in the build file, you can get rid of these and use. And we can finally create an executable. Call it hello, I guess. And build add txt. Call it hello. Now we need to add the build tools. Set build tools. You need to take hello and the CC. But the archiver can be null since it's just an executable. The build options. It needs, right, what does this need? The object and to out file. I got it reversed and the archiver doesn't really need it since this is an executable. Now let's try to create this thing. So cc-o build Linux. Now what, let's try to add the debug info and call valgrind on this. Now instead of calling valgrind, since we want to be uh, independent from other executables as much as possible, let's use asun address. There you go. Now run build. Wait a minute. 186. Oh, that's embarrassing. Where was it again? 186. Here. Where? But I've done This wrong though. Should not be equal to null. Then what else? Did I copy that assert incorrectly? Nah, it's fine. There you go. Leak. 142, 152, 155. Did it not read the name? I'm pretty sure it did. Oh no, it did not. Hold on. Hmm. I'm an idiot. I did not do this. D flags, LD flags, and the full command. There you go. That should fix it. There you go. Now there's only one leak left from 140. So we need to free the actual target. That's understandable. So we can free itself. Free T. There you go. But I don't think it actually created the actual exe. Oh, no, no, no. No, no, no. That is wrong. But at least we have caught it early. So we can build the executable here. Recompile this. Build it. Hold on. 3:15 now. Mm-mm. Did not want to append the compiler. That is weird. So trying to add it to null. But full CMD was initialized though. Here. That would be a pain to debug. Very weird. So I tried to append the compiler name, which I'm pretty sure was copied correctly. The build to see it was copied over here. Yeah. I wonder why. Well, I guess we have no choice. We have to call on to Valgrind with most options set. Go on, Valgrind. I believe in you. Stagfall. Empire read size of 8. There's it tried to read a pointer from 315. It was not freed yet, though. Hmm. There is a problem with the compile. Well, let's remove that for now and try to print the compiler first. The compiler name here, printf. Build it, check it. Eh, thinks it's null, or it thinks that E is null. No, it doesn't think. Probably sending E as null here. Yeah, this is the reason. Now we finally got it. That is embarrassing. Okay, that's a bit better. That's way better. Remove these. And actually, add sources, which are from test source, main. Let's see. Instead of using Valgrind again, gonna use ASUN. There you go. Hello. We finally built an executable after coding for a bit over an hour. Thank you for sticking this far with me. And in the next video, we will try to make the executable from object files, I guess. Thank you and goodbye.